Hello students, now we have already seen the photochemical reactions with respect to olefinic bond. Now we shall go to the reactions of carbonyl compounds, that is photochemical reactions with respect to the carbonyl compounds. So as you can see, so carbonyl compounds have two absorption regions in the UV spectra. One at 285 nanometer and another one at 180 nanometer. So in case of carbonyl, as we see in olefinic compounds or alkenes, their pi to pi star transition happens, but in case of carbonyl compounds we observe n to pi star transitions, that is non-bonding electron of oxygen are promoted to the pi star antibonding molecular orbital. So due to the small energy gap between excited singlet and triplet state, ketones undergo intersystem crossing, that is ISC, with a high degree of efficiency. So most of chemical reactions of ketones arises due to the triplet state. So coming to the reactions of carbonyl compounds, the most important reactions of these carbonyl compounds are Norris type 1 and Norris type 2 reactions. So other way, these two reactions are also called as Norris type 1 reaction is called as alpha cleavage, Norris type 2 reaction is called as beta cleavage. So as in case of Norris type 1 reaction, so you can see here the acyclic saturated carbonyl compound undergo an initial cleavage of carbon-carbonyl bond to give an alkyl and acyl radical. So this is known as Norris type 1 reaction. So please listen carefully once again. The acyclic saturated carbonyl compound undergo an initial cleavage of carbon-carbonyl bond to give an alkyl and acyl radical. This is known as Norris type 1 reaction, or it is also called as alpha cleavage, that is the bond breaking happens at the carbon-carbonyl bond. So photochemical excitation of ketones usually causes the homolytic fission of alpha carbon bond. So as we know, this process is termed as alpha cleavage or Norris type 1 reaction. So in the example, we have taken any ketone. So under light radiation H mu, it undergoes homolysis, that is bond breakage at the. So as you can see, at carbonyl bond, the breakage happens at the carbonyl carbon-carbonyl bond and gives rise to two products. One is acyl radical, another one is alkyl radical. The first product is acyl, where we have carbonyl radical, and second one is an alkyl radical. So these are acyl free radicals, that is carbonyl free radical you have in the first. So then you have alkyl, so alkyl free radical. So this reaction doesn't stop here. So this acyl free radical, which is formed as a product in the photochemical excitation of ketones, it undergoes again following three different processes. So one is disproportion to give a ketene. So another one is intermolecular hydrogen atom abstraction, that is abstraction of hydrogen atom by acyl radical. Another one is decarbonylation, that is removal of carbonyl group or carbon monoxide group, followed by disproportion or dimerization. So now we shall see one by one reaction. So disproportion to give ketene. So you can see here the products which are formed in the reaction, that is homolysis of carbon-carbonyl bond, or CH2 carbonyl group plus R dash CH2. So these two combine to form, that is, this is a disproportion to give a ketene, to form a ketene and alkane. So you can clearly see here. So the first one is disproportion to give ketene. This is also an recorded as abstraction of hydrogen atom. Here in this case, the hydrogen atom from acyl radical is donated to the alkyl radical, and thus it forms an alkane. So these are, here you can see there are only two types. One is abstraction of hydrogen atom by cell-free radical or disproportion to give ketone. Both are same. So you can also disproportion reaction to give ketene is also you can term as abstraction of hydrogen atom. That is abstraction of hydrogen atom from acyl-free radical to alkyl-free radical. The hydrogen atom which is present in the acyl group is donated to the alkyl group and it forms a ketene and alkane. So second one is intermolecular hydrogen atom abstraction by the acyl radical. So here also the hydrogen atom present in the alkyl free radical is donated to the acyl radical and thus it forms aldehyde and alkene. Right? So this is second product, second type of reaction which the acyl free radical and alkyl free radical undergoes. So third one is decarbonylation. Decarbonylation, again it is followed by disproportion or dimerization. So here two acyl free radical combines to give an alkyl free radical and carbonyl group. This is one way it may happens, or this acyl radical undergoes a disproportion reaction. So disproportion reaction or disproportionation, so it gives, and that is removal of carbonyl group happens. So as you can see here, so first it forms an RCH2CH2 group by the removal of carbonyl. So this radical which has formed, it undergoes disproportionation and it gives an alkene and alkane. In case of dimerization, it forms a dimer or CH2CH2 single bond CH2CH2R. So, right, these are the three ways the radicals which are formed. So Norris type 1 reaction is where an acyclic saturated carbonyl compound undergo cleavage of carbon-carbonyl bond, that is bond breaking at the carbonyl bond to give an alkyl, that is acyl and alkyl free radical, and these acyl and alkyl free radicals are formed undergoes three processes. One is disproportionate to give ketene, or it is abstraction of hydrogen atom we can call by acyl to alkyl. So another one is again abstraction of hydrogen atom from alkyl to acyl. So decarbonation followed by disproportionation or dimerization, that is removal of carbonyls group give rise to another free radical or CH2CH2. This undergoes a disproportionation and dimerization. So whenever you are asked, so explain Norris type 1 reaction, you have to explain all these three processes along with the main reaction. So we can take an example of a stone. So a stone which gets photolized, that is undergoes photochemical reaction in vapor phase as well as in liquid phase. So absorption of light gives rise to a formation of an N to pi star exit state of a stone which undergoes a carbon-carbon cleavage to form an methyl radical and acetyl radical. So it forms a methyl radical and acetyl radical. At room temperature, these two acetyl radicals undergo combination to form a biacetyl. So you can see here it is formed. So stone, so it forms intermediate state and from and methyl plus CH3C double bond O. This is an acetyl free radical. The acetyl free radical undergoes combination to form biacetyl. It is 2 CH3C double bond O gives rise to CH3C double bond O single bond C double bond O CH3. So temperatures above 100 degree, acetyl radicals get decarbonylated with the ultimate formation of ethane and carbon monoxide. So in unsymmetrical ketones, splitting occurs in a way for generating the more stable of two possible radicals. CH3COCH. So you can see this is an unsymmetrical ketone, CH3CO CH3 twice. Under photochemical irradiation, it forms an CH3CO free radical plus CH3 twice CH free radical. So CH3CO CH2 CH3, and again photochemical irradiation, it forms CH3CO and unsymmetrical, that is a ketone plus CH3 that is it forms CH2 CH2. So most of the excited molecules involves intersystem crossing to T1 at room temperature, but with increase in temperature less interstate conversion occurs, and thus both the species do participate in Norris type 1 reaction. So this is again give an example for acetone. So this is all about Norris type 1 reaction. So that is cleavage happens at the acyclic saturated carbonyl compound to give acyl and alkyl free radical. So coming to the Norris 2 type 2 reactions, so ketones having a gamma hydrogen atom undergoes photochemical reaction where intramolecular abstraction of gamma hydrogen atom occurs by cleavage or cyclization of diradical to form an aldehyde or ketone or cyclobutadiene respectively. So here you can see the reaction. So I have taken a ketone which having a gamma radiation, that is gamma hydrogen atom, or C double bond O, CH2 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 R. So you can see the gamma hydrogen mentioned at this place. So first of all, when it is irradiated with the photochemical radiation, so first the cleavage bond breaks of the carbonyl group and forms the two electrons are distributed, one at carbon, another on hydrogen. So this radical which is formed, so this radical which is formed, so it gives rise to an RCOH, then CH2 CH2 CH R dash. So now the bond breaks at the beta carbon atom. So when the bond breaks at this beta carbon atom, so this is called as beta cleavage. So it forms a 1,4 biradical. So when it breaks at this beta carbon atom or beta hydrogen, what we call, so first it forms two products. One is RCOH CH2 and an alkene CH R dash double bond CH2. So this aldehyde which forms undergoes again a change to form a ketone. So this is one type, that is gamma hydrogen or type 2 reactions happens in the case of compounds which are having at least one gamma hydrogen atom, and it forms at the beta carbon atom. Cleavage happens at the beta carbon atom to form two products. One is ketone and alkene, that is formation of 1,4 biradical happens, and this undergoes again cleavage to form a ketone and alkene This 1,4 pi radical which has formed, instead of going for cleavage to form ketone and alkene, it can undergo cyclization to form cyclobutanol derivative. So there is two process which happens in this Norris type. So one is uh, breakage of 1,4, that is cleavage of 1,4 pi radical. Another one is cyclization. So it forms a cyclobutanol. So right, if the alpha carbon atom has only one hydrogen atom on it, major product is the carbonyl compound. But if it has alkyl substituent, major product would be cyclobutanol derivative. Norris 2 type reaction is possible if bond between alpha and beta carbon is weak. Right. So this is about Norris type 1 and Norris type 2 reactions. So in Norris type 1, it forms acyl and alkyl free radical. So these two combine and again undergoes three processes. Intermolecular of one is disproportion to give ketene, intermolecular hydrogen atom abstraction by acyl free radical, and one is decarbonation followed by disproportion or dimerization. So you can explain with the example by taking an acetone. So in case of Norris 2 type reaction, so ketones having gamma hydrogen atom undergo this type of reaction to give an aldehyde or ketone or cyclobutanol derivative. So as in case of olefins, the excitation happens with the pi to pi star. So but in case of carbonyl compounds, the excitation happens from the non-bonding orbital of the carbonyl group to the antibonding pi orbital, that is pi star orbital. So n to pi star excitation happens in case of carbonyl compounds.